So in these examples, what we'd like to do is still continue our work with synthetic division, but look at some different polynomials which may have factors or binomials that are not factors, and also some of these weird oddball ones as well. So for example, let's look at the polynomial 2x squared plus 7x plus 9. I'm going to write this slightly different also. I want to know if I divide this by x plus 2, I want to know what is my result and if x plus 2 is a factor. Very similar to the same work we were doing in the previous section or the previous examples, but writing it slightly different. So again, I'm taking this polynomial up at the top. Now notice that this is a second degree polynomial. I have a squared, a first degree, and a constant. And I'm going to write those coefficients down as well, same as I did last time. Again, I need to figure out what I'm going to place on the outside, and this x plus 2 is my divisor. So again, I can't put x plus 2 on the outside. I need to first figure out when is x plus 2 equal to 0. And that's going to help me to figure out what goes there. So on the outside, I'm going to put a negative 2. So let's drop our first 2 down and multiply. Negative 2 times positive 2 is a negative 4. 7 minus 4 is 3. And last, negative 2 times 3 is negative 6. And when I add these up, I get 3 as my remainder. Now, in long division of polynomials in our previous notes, when you have a remainder, then that gives us a lot of really good information. First, this is going to mean that the divisor is not a factor. If this does not come out evenly or does not come out with a 0 remainder, then that doesn't create us a factor or a 0. It's answering a question for us. Now again, if I look at the digits I used, because I started off with something squared, again, this was a coefficient on the square, 1 degree less, and my constant, which means my result here, again, is still 1 power less. X squared divided by an x gives me an x as my coefficient, or sorry, my variable. And if this is got the x to the first power, this is my constant. It always has to be 1 degree less, just like in the previous section. Squared, first degree, no degree. Right? First power, no power. So when I write my result is just 2x plus 3, but because I have a remainder, I have to also include the fraction just like I do with other mixed numbers. Plus, I also had a 3 that was being divided by this x plus 2. So just like in polynomial long division, when I come up with a 0 remainder, I not only have my result after division, but I also have a fractional piece that was left over. And again, if I want to answer the question, is this a factor or not, then again, that means that the divisor, which was x plus 2, is not a factor. And so very similar to our previous long division, but we're kind of getting now into creating these results with fractions as well. So notice the difference again between having a 0 remainder and having a remainder of something else. 0 remainder, I end up with a result with no fractions, and the divisor is a factor. When I have some remainder, doesn't matter what it is, my result includes a fraction, and the divisor is not a factor. So let's look at one which is, again, it's going to give us a result similar to this last example, but slightly different. So I'm going to have to move my paper over a little bit. I'm going to kind of come up here to this section. I'm going to give myself a little example. And what I want to know is I want to know if 3x to the fourth minus x cubed plus 5x minus 1 is divided by x minus 3, I want to know what is the result, and is this x minus 3 a factor? Now, something to look at. My polynomial that I'm dividing into. This polynomial is in descending order, but is missing a term. I have my x to the fourth term, have an x cubed, I'm missing an x squared term, and that's going to cause a problem. So what I need to remember is that I have to have coefficients all listed. I need the coefficient on the x to the fourth, the coefficient on the x cubed, which again is a -1. I have no x squared terms, so I need this placeholder. This is extremely important that we have a placeholder anytime we are missing a term. Then the coefficient on the first degree and the constant. So let me get my little division box right here. And again, think about what's going to go here. If you have to go off to the side, again, I need to know when x minus 3 is going to be a 0. So I'm going to add 3 to both sides. And so the value I'm going to use is when x is a positive 3. Now let's start our process. Drop the first digit down so I can use it to multiply. 3 times 3 is 9. When I add those together, I get 8. 3 times 8 is 24. So you can see that if I didn't have this placeholder here, some things are going to be off-shifted kind of funny. 0 plus 24 is 24. Now I'm going to need to do a little bit extra work because 3 times 24, I'm not sure. So I need to think about maybe go off to the side, do some extra work. Now I know it ends in a 2, and I believe the number is 72 that I'm going to use. I'm just going to double check that. I'm going to kind of like do this little mental math here, and it looks like it works. So 72 plus 5 is 77. So I'm getting into some big numbers here. I clearly can see that this is not going to be a divisor. 3 times 77, and I know it ends in a 1. I think it's 231. And so when I add those together, I get 230. That's my remainder. Holy cow. And I'm writing it right off the page, so I'm just going to write rem for remainder. So I can clearly see that this has a huge, huge remainder. Now look at the line at the top that I use my coefficients. Again, this is the coefficient on the x squared, x cubed. Sorry, x to the fourth, x cubed, x squared, x, and my constant. And so what happens is when I look at my result, 1 power less makes this x cubed, x squared, x, and then my constant. And so if I didn't have this placeholder, all of this would kind of been shifted funny and messed up. So it's super important that I have this placeholder digit when I'm missing something like right here. However many I have, if I am missing any of the powers in descending order, it needs to be there. So let's write our result. 3x cubed plus 8x squared plus 24x plus 77 plus, let's see if I can get it on here, 230 divided by my divisor, which was x minus 3. And again, what does that mean in terms of the factor? That means that x minus 3 is not a factor. Right? So it's very important when you are showing your work that you are showing the type of division that you're doing, whether it's synthetic, long division, that you show the whole process neat and organized, and that you write the 2 pieces of information you get from that division. What is the result and what is the factor?